Mm. Today's lesson is complex numbers. One of the important lesson because we have two questions. Part 1 question, that is also very easy. Part B question is a type question, right? Now the complete question, part A, you have a question, complete question. Normally it has 3 parts now. Major portion of that sum is complex numbers. Part is matrices. නේද? දැකලා තියෙනවානේ සම් මේ අපිට part B එකේ කියන සම් එක තුයි. ඒක කොටසක්
ඔව් සර්.
පොඩි කොටසක් තියෙනවා matrices and matrices වලින්. Other part other part is complex numbers, right? But 2019 onwards you have another new section. That is the Moore theorem. The Moore theorem part also there now. That's why 3 parts in that sum. Part A of the paper, you have 25 marks sum. Ekak lazy. Using Argon diagram, you have to resolve. Argon diagram එක භාවිතා කරලා කරන කොටසක් තියෙනවා අපිට part A එකේ paper එකේ නේද? ඒක මේ බොහොම ලේසි. ඒක ගොඩක් වෙලාවට අපිට එන්නේ half line එකක්. half line එකක් සම්බන්ධ කරගෙන තමයි ඒක ඇතුළේ එන්නේ. So you can prepare for both the sums. Right? Right. Let's start this lesson. What do you mean by a complex number? How do you form a complex number? What is the difference between complex numbers and real numbers? Complex numbers
Real numbers can be written in real numbers can be written in divide
complex numbers are actually complex numbers generally formed by due to imaginary numbers. You know that if you take any number, how do you find the square root of negative number? Can you find the square root of negative number? Right? Square root of negative number. For example, minus root 4. Can you find the value of this? If you take
we should take negative 1 root out and then
2 into minus root 5. How do you find the root minus root 5? Right?
We take a negative 1 minus 1 root out.
Yeah. Somehow, in generally, these are not real. So we call these numbers imaginary numbers. Right? Imaginary numbers. For example, if you take minus 2 plus minus 5, right? Can you evaluate this number in real manner? In real manner, you cannot evaluate this number, no? Because both we don't know how to find the square root of a negative number. For example, if you know that square of any number is always positive. Now square root of for example, if you take minus 2 square, this is plus 4. Then if you want to find square root of minus 4, somehow you have to find a number. If square of that number should be minus 4. Right? Can you find the value for x satisfying this equation? You cannot find. That means you cannot find the square root of a negative number. Right? These numbers are not real. These numbers are not real. They are known as imaginary numbers. Right? Imaginary numbers. So imaginary numbers you can write, if you take a real number plus imaginary number, that is also imaginary number. Right? Now if you take 4 plus minus root 12. If you take this number, this is also imaginary number. Imaginary. Imaginary number. Imaginary number. But how do you express this imaginary number? Formal way. Right? In formal manner, how do you express these numbers in formal manner? So you can take minus 1, square root minus 1 you can take as I. Right? Take like this. Take this. Then these imaginary numbers can be expressed in formal manner. Right? For example, if you take minus square root 4, you can write this one plus root 4 into minus square root 1. So this equals 2y like that. All numbers. For example, if you take 4 plus minus root 12, this can be written as 4 plus root 12 into minus root 1. So this equals 4 plus 2 root 3 times I. Right? You can take square root minus 1 equals I. In other words, where I squared equals minus 1. Right? These numbers are known as complex numbers. These numbers are known as complex numbers. But complex number also you can express in formal way. How do you express a complex number in the formal manner? What is the definition of complex number? Definition of a complex number. Right? Definition is any number in the form of a plus ib is said to be a complex number. Complex number where A and B are real and I equals square root minus 1. Okay? Square root minus 1. So you can copy it. Is it clear? But so you can use, you can take letter Z to denote a complex number. So a plus ib. In this number, a and b are real numbers. I equals square root minus 1, right? If you take z equals a plus ib, what is so this part, a is known as real part. A is real part. Real part of z. Also real z. This is denoted by real z. B equals imaginary part. Part of C, that is known as implicit. Is it clear?
Yes, sir.
Right. Now, very important thing is both A and B, both real part and the imaginary part, both real, right? Of a complex number, both imaginary part and real part, both real part and imaginary part, both real. Very important, right? හැමතිස්සෙම රියල් පාර්ට් එකයි ඉමේජිනරි පාර්ට් එකයි දෙකම රියල්. ඒක මතක තියාගන්න දුවේ. right? ඉමේජිනරි පාර්ට් එක උනායි කියලා ඒක රියල් ඉමේජිනරි නෙවෙයි. right? Then how do you say complex number can be imaginary? Under what condition a complex number is imaginary? Can you tell me, Dwi?
When b is not equal to 0?
Hmm?
When b is not equal to 0?
When b is not equal 0. If b equals 0, a complex number is a real number. Very good, Dwi, right? If b equals b non-zero, if b not equal 0, then C is an imaginary number. If b equals 0, then C is a real number. Right? Example, now real number, now all the numbers, if you take all numbers like this, there are many numbers you can write. Examples. If you take 2 plus 3i, so this is imaginary number, right? If you take 2y, this is imaginary number. If you take 1 minus I, this is an imaginary number, right? All these are imaginary numbers. Then examples. 2 minus 1, 5, e, etc. are real numbers. Can you consider a real number as a complex number? Real number
No,
එක
sir.
complex number එකක් විදිහට ගන්න පුළුවන්ද?
No, sir.
Can. Any real
How,
number
sir?
is a complex number. But complex number, if the real number is not an imaginary number. Is it clear? All real numbers are complex numbers. Right? These are complex numbers. 2, -1, 5 are complex numbers according to definition. Under b equals 0, if b equals 0, it is a real number.
Yes, sir. Now I understand.
Right? b not equal 0, only g is an imaginary number. Right? That means, what do you mean by that? Complex number set includes the set of real number. Right? That means set of real number is a subset of complex number set. Right? Right? Now if you take this complex number set, right? Set of complex numbers, these complex numbers, then real number set is subset of this real number set. Then what is outside this real number? What is this number? This imaginary number. Right? This part is imaginary number. Okay.
Yes, sir. Now I understand, sir.
Right. Now you should, if you have any problem, ask me. If you have anything you cannot understand, ask me.
Okay, sir.
Right. We take modulus of a complex number. So if g equals x1 plus iy1, right, then modulus is denoted by modulus is denoted by like this, and this is equals x1 squared plus y1 squared whole thing square root. Okay? x1 squared plus y1 squared. In conjugate of a complex number, if c equals x plus iy, then the conjugate c bar equals x minus iy. What is c into c bar? If you take c into c bar, x plus iy into x minus iy. Now you have difference of squares, no? difference of squares. So this x squared minus I squared y squared. I squared is minus 1, so this equals x squared minus y squared, that is x squared plus y squared. What is x squared plus y squared? Mod z squared. This is very important, right? Most of the times we use, in most of the past papers, we often use this result, right? Very, very important. C into C by equals mod C squared. So this is very important, right? Very often we use this result in most of the past paper sums. This is very important. Right. Then how do you do algebraic operations with complex numbers? How do you manage algebraic operation on complex numbers? Complex number is a separate number system, new number system, right? New number system. Complex numbers are new number system. But that number system includes real number system also. But those numbers formed by imaginary numbers. Imaginary numbers. Although numbers are imaginary, you can apply normal, the ordinary mathematical operations. What are the ordinary mathematical operations normally you do on real numbers? Anyway.
Like subtract, divide, multiply.
That's right. Right? Multiplication, addition, subtraction, etc. Taking powers. Is that all? Exponent of a number. Right? There are many operations under on real number sets, right? Real number set. Can you use those operations for complex numbers also? Because this separate number system, would you think those operations also applicable? Right? Yes.
Applicable, sir.
Applicable, because those numbers also formed by real numbers, right? Square root of real numbers, right? Actually, all those numbers are square root formed by square roots of real numbers. So, mathematical operation. Then, how do you take addition of two complex numbers? Addition of two complex numbers. Two complex numbers. Right? If C1 equals x1 plus iy1 and C2 equals x2 plus iy2, right? Now this is an ordinary form of complex number. If I mention C equals a plus ib or C1 equals x1 plus iy1, what can you say about x1 and y1 to you? You have to, from now onwards, if I express like this, x1 plus iy1, x1, y1 are real numbers, right? Here x2, y2 are real numbers, No need to purge simplify to get the complex numbers. This is a general form of a complex number. These x1, y1, x2, y2 are real numbers, right? දැන් දුවේ අපි ආපහු හැමතිස්සෙම අපි දැනගන්න ඕනේ මේවා real numbers කියලා, right? x1, y1, x2, y2 කියන.
Okay, sir.
Right? Then how to define it? Then what is g1 plus c2? c1 plus c2 obtained by adding real parts separately and imaginary parts separately. Then x1 plus x2 plus I times y1 plus y2. Right? I1 plus I, y1 plus y2. Right? Like this. Example, if C1 equals 2 plus I and C2 equals 3 minus 4I, then C1 plus C2 equals 5 minus 3I. Okay? C1 plus C2 equals 5 minus 3I. Okay, do you?
Yes, sir. Okay, sir.
Now you know these numbers are mainly in all real part and imaginary parts. When you know mathematical operations, multiplication, addition, squaring, etc., you can manage in the same way that you did for real numbers, right? But in the same way. For example, if you take, let's say, C1 equals 2 plus 4I. How do you find how do you find C1 squared? And C2 equals, let's say, 1 minus I, like that, this C2. Then what is G1 squared? What is C1, C2 cube? What is C1 plus C2? How to get the product of these two complex numbers? How do you take the division of these two complex numbers? C1 over C2. Let's see how you can manage it. The C1 squared is 2 plus 4I whole thing squared. In normal manner, you can, in an ordinary way, you can square this, right? 4 2 squared plus 16I plus 16I squared, like this, right? Then I squared is minus 1. Here I squared is minus 1, 4 plus 16I plus 16 into minus 1. So this equals minus 12 plus 16I, right? 16I. So if you take C1, C2 cube, C2 cube is 1 minus I cube. So 1 minus I times 1 minus I squared. 1 minus I times 1 minus 2I plus I squared. But I squared is minus 1. 1 minus 1 is get cancelled. I squared is minus 1, right? Then you can multiply by minus 2I plus 2I squared. So this equals minus 2 minus 2I. Here I squared is minus 1. This term becomes minus 2, right? This term I wrote here, right? Okay. Like that you can simplify. Then what is C1 into C2? 2 plus 4i times 1 minus I. Two minus 2i plus 4i minus 4i squared. So this equals 6 plus 2i. Then part 3, C1 over C2. How do you simplify C1 over C2? 2 plus 4i over 1 minus I. So try to express this complex number in the form of a plus ib, right? Always you have to express this complex number in the form of a plus ib, where a and b are real numbers. So you have to express in this form. This one you have to bring this into this form, right? A plus ib ආකාරයට මේක ගේන්න ඕනේ. කොහොමද ගේන්නේ? How do you simplify this? What to do next? If you bring this one to this form, what would you do to it?
So we can multiply by conjugate and try?
Yeah, conjugate of the bottom. What is the
Yes,
conjugate
sir,
of the bottom? Top and bottom you can multiply by the conjugate of bottom, 1 plus I. Then bottom you have one difference of square, then 1 minus I square. Right? 1 minus I square. Minus minus 1, then bottom becomes 2. Bottom becomes 2. Then top you can multiply 2 plus 2i plus 4i plus 4i square. So this equals 2 minus 4. I squared is minus 1, this becomes minus 4. 2 minus 4 minus 2 plus 6i over 2. So this equals minus 1 plus 3i. Right? You should be able to bring this complex number into this form. Okay. The complex numbers are satisfy commutative law, associative law, distributive law, etc. What is the commutative law, do we? Have you heard it?
Yes, sir. The order of the two elements doesn't affect the final answer when it is.
For real numbers, can you say what is commutative law? For real numbers, what is the commutative law for real numbers?
So it's like 2 times 3 is 6 and 3 times 2 is 6, like the order of the elements in algebraic.
That is a plus b equals b plus a. Right. This is a commutative law. This is a commutative law under addition. Commutative law.
Yes.
Commutative law on multiplication, ab equals ba. Right. Associative law, a plus b plus c equals a plus b plus c. This is associative law, right? This associative law on addition. Associative law on multiplication, ABC equals ABC, right? ABC. Okay, this is associative law multiplication. What do you mean by that? B plus C, if you take, this means, plus you add B plus C, then you add that amount to A. That is the meaning of that. Here plus do operation between A and B, thereafter A plus B add to C. That is the meaning, right? දැන් දුවහයි මේක ඔබ්වියස්ලි මේක කියන්න දෙයක් තියෙනවා මොනවද මේ ලියන්නේ කියලා නේද මටත් හිතුණා එල් කරන කාලේ පහල නේද එහෙම හිතන්නේ නැද්ද මේ මොනවද මේ කියන්නේ කියලා හිතුවා මටත් එල් කරන කාලේ කවුද කොම්ප්ලෙක්ස් නම්බර්ස් ගන්නකොට කවුද කියලා මට හිතුණා එහෙම මොකක්ද මේක දෙයක් තියෙනවා මේක එහෙම හිතුනේ හිතෙන්නේ නැද්ද ඒක නිසා වැඩක් නැහැ පුදුයි ඇත්තටම. මේක වටින්නේ දුවේ අපි තව නම්බර් සිස්ටම්ස් ඉගෙන ගන්නකොට. අපි නම්බර් සිස්ටම්ස් සාමාන්‍ය LL වලදී ඉච්චර ඉගෙන ගන්න නැහැ නේ. ඔය කොම්ප්ලෙක්ස් නම්බර් සිස්ටම් එකකින් ජෙනරේට් වෙච්ච කොම්ප්ලෙක්ස් නම්බර් සිස්ටම් එක තමයි අලුත් නම්බර් සිස්ටම් එකක් විදිහට ඉගෙන ගන්න. අපි යුනිවර්සිටි ලෙවල් එකට යනකොට එක එක නම්බර් සිස්ටම්ස් ඉගෙන ගන්න. එතකොට අන්න ඒවේ වටිනකම තේරෙනවා මේවා. කොමියුටේටිව් ලෝ. දැන් මේට්‍රිසස් ගත්තොත් කොමියුටේටිව් ලෝ එක හරියන්නේ නැහැ දුවේ. Commutative law is not valid for matrices. So if you take two matrices, AB not equals B in general.
Yes, sir.
AB not equals B. That is the system of matrices. Likewise, there are many systems, right? Many systems of elements, right? There might be numbers, polynomials, vectors, etc. Various types of systems, number systems, right? We learn. We define different operations also. Normally under LL we learn only multiplication, addition, multiplication, addition, division, subtraction, etc. Right? So you can define different mathematical operations, different mathematical systems, etc. We discuss undergraduate mathematics, right? Then you will see these things are important. But you know that complex numbers also form by real numbers. Most of the mathematical operations are applicable. If you want further check, these laws are correct for complex numbers. All these laws are correct complex numbers also. Other law is distributive law. This A times B plus C equals AB plus BC. This distributive law of multiplication or addition, right? Likewise, this is true. But if you take distributive law over multiplication, is it true? No. A plus B, AC, A plus C. This is not true. This is a distributive law over distributive law of addition over multiplication. This is not true in general. For real numbers, we make, right? You can't. So these laws correct for complex numbers also. If you take any two complex numbers, C1 plus C2, C1 plus C2 equals C2 plus C1. Very easily you can prove. I am not going to prove these things, right? मैं प्रूव करने नहीं दूँ निकां काले नष्ट करना उन्हें मान निकां आलो टिका सदां के लो इधर है C1 times C1 C2 equals C2 C1 C1 C2 C3 equals C1 C2 C3, right? For complex numbers also very easily prove, right? These laws are applicable, right? These properties are true, right? Commutative property, associative property, distributive property, right? All these rules are true for complex numbers, right? Then can you prove this one? The modulus of C1 G2 is equals modulus of C1 into modulus of C2. Modulus of C1 over C2 equals modulus of C1 over modulus of C2. Can you prove this one?
Okay, sir.
Can you manage this one? Make manage.
I can, sir.
How do you start?
So with the assumption of the Z1 is x1 plus I times y1 and Z2 also x2 plus I y2, and then
Yeah,
A is a module.
yeah. So you can start like that. Yeah, you can be right. Okay, I will give me 5 minutes. You do this example. Right. So you can take this is the first one. This is the second one. So if you take let C1 equals x1 plus Iy1, C2 equals x2 plus Iy1. So you have to take like that. Then take C1, C2, the product C1, C2, right? That is x1 plus Iy1, x2 plus Iy2. So this equals x1, x2 plus I x1 y2 plus I y1 x2 plus I squared y1 y2. So this equals x1 x2 minus y1 y2 plus I times x1 y1 plus y1 x2, right? Now C1 C2 is in the form of a plus ib. This is the real part of this complex number, this is the imaginary part of complex number. Now you can take the modulus of this one, modulus of the product, right? Modulus of the product is x1 x2 minus y1 y2 whole thing squared plus x1 y1 y2 plus y1 x2, x1 y2 plus y1 x2 whole thing squared square root of this. Right? You can simplify x1 squared x2 squared plus y1 squared y2 squared minus 2 x1 x2 y1 y2 plus x1 squared y2 squared plus y1 squared x2 squared plus 2 x1 x2 y1 y2. So this is the middle term of this term. So this is the middle term of this term. Both get cancelled, right? And square root also there. Square root also there. Then you take x1 squared out, x2 squared plus y2 squared. Then take x2 squared out, sorry, y1 squared out, x2 squared plus y2 squared. Then take x2 squared plus y2 squared out. So this is equals x1 squared plus y1 squared, x2 squared plus y2 squared. So this equals C1 mod C1 into mod C2. Therefore, mod C1 C2 equals mod C1 into mod C2. Right? Did you get the answer in this manner?
Yes, sir.
Then make a epsilon plus you have to take the product of this. Without taking product, you can find the modulus of this. No? Plus you multiply these two and write this, right? Then now this is in the a plus ib, in the form of a plus ib. Then you can take the modulus of this product, right? Separate. Then you square and this one, you can simplify, you can get the, you can factorize inside the square root side, right? Like this. Then you can express the product of these two numbers, that is actually mod C1 into mod C2, right? So you can solve this result. Now if you take C1 over C2, same way you have to simplify this one also. First you simplify, algebraically you simplify this one, right? When you simplify, you have to take the conjugate of the bottom. Top and bottom you multiply by the conjugate of the bottom. What is conjugate of x2 plus iy2? x2 minus iy2. Both top and bottom you multiply by this number. Then you had, on the bottom you have difference of a square, that simplified to x2 square plus y2 square, because I squared is minus 1, here become plus. Then in the top you can take the real part separately and imaginary part separately. You can arrange like this. Entire complex number now in the form of a plus ib, right? Now you can take the modulus. Now if it is in the form of a plus ib, now you can take the modulus of C1 or C2. That is the square of the real part plus square of the imaginary part, like this. Okay? Right. Then this part you can take out. Here this square is applied to these two also, no? Then when you take it out, you get like this without the square root. Is it clear?
Yes, sir.
Right. Thereafter you expand this term and this term. The middle term of this term is this term, 2x1, x2, y1, y2. Here the middle term of this one is 2x1, x2, y2, y1. Those two get cancelled here, right? Thereafter you factorize, take x1 out, then x2 square plus y2 square, then take y1 out, y1 squared out, x2 square plus y2 square. Then again take x2 square plus y2 squared out, you get like this. Then apply square root separately, you get like this. Then here, this term without square root, right? You can write square root into square root, that term, in the form of square root into square root, this term. Then one term get cancelled, then you get, this is mod C1, this is mod C2. Is it clear?
Yes, sir. Now clear, sir.
Right. What do you mean by Argand diagram? What do you mean by Argand diagram? What is Argand diagram? Do you know about Argand diagram? So you can use familiar OXY Cartesian coordinate system for denoting complex numbers, right? You can use ordinary Cartesian coordinate system for representing complex numbers. For representing complex numbers. That is, ordinary coordinate system, OXY plane, right? Rectangular Cartesian coordinate system. This x-axis, this y-axis, right? X-axis. So this is known as imaginary axis. So if you take Z equals a plus ib, right? This complex number can be represented by the coordinate AB, right? You can take simple A x coordinate, simple B y coordinate, right? Like this. Point P, AB, right? AB. That means x coordinate is A, y coordinate is B. Okay. A rectangular Cartesian coordinate system can be used for representing complex numbers. Any complex number in the form of Z equals A plus IB can be represented by the point P A comma B like this, right? Then x-axis is this x-axis is known as real axis and y-axis is known as imaginary axis. Right? Is it clear? Okay.
Yes, sir.
Not only that, now if you take what do you mean by mod C? Mod C is actually a squared plus b squared whole thing square root. So far we discussed mod C, modulus of a complex. What do you mean by modulus of a complex number? In terms of what is the geometrical meaning of the modulus now? Now you have different meaning, geometrical meaning for the modulus. What is the modulus? What do you mean by modulus? Now you have
the length of the
just length
line OP.
Length OP, yes. Just length. Now you have geometrical meaning. Geometrical meaning for mod Z. That is, mod Z equals length OP, right? Always, modulus of a complex number is the distance from origin to that point representing the complex number, right? Now it has geometrical meaning. What is the polar form of a complex number? Write down polar form of a complex number. What is polar form of a complex number? Polar form of a complex number. Now if you take any complex number, all complex numbers, there's a specific point in the Argand diagram. Any complex number, it has the position on the complex number. Point is allocated on the complex plane, right? If you take any complex number, right, there's a point allocated on the Argand diagram, right? අපි ඕනම complex number එකක් ගත්තොත් එයාට point එකක් වෙන් වෙලා තියෙනවා Argand diagram එකේ. right? For any complex number, right? Then, what is the polar form of a complex number? Polar form means, now you can take, if you take any complex number, you can take this angle theta, where that OP makes with x-axis, positive x-axis. For a given complex number, can you tell me what is the range of values of theta? For a given complex number, what are the possible values of theta? What is the range of values of theta for a given complex number? Anyway,
So 0 to 2 pi.
0 to 2 pi, yes. From 0 to 2 pi, right? But different angle. For example, let's say complex number is in the second quadrant like this, right? Piece. Then theta is this angle, right? Let's say C equals minus 1 minus I. How do you mark this complex number? What is the point? This side, no? X coordinate also minus 1, this minus 1, this also minus 1, this point, this angle, right? Theta vary from 0 to 2 pi, but we define as angle called amplitude of a complex number, right? Amplitude of a complex number. But so you can measure angle from 0 to 5, 0 to 2 5, or so better to write like this: theta greater than equal 0 less than 2 pi, or theta greater than minus 5 less than equals 5, like this. Theta, you can define theta in two different ways, right? So this theta is known as argument, right? The older syllabus we define theta like this. Theta, argument of a complex number. The complex number, any complex number made with positive x-axis is known as argument of the complex number, right? This argument of a complex number can be defined according to our new syllabus from minus pi to theta greater than minus pi less than equals 5, right? Like this you define a principal argument of a complex number, right? Principal argument of a complex number, right? So you keep in mind that one principal argument always you measure from minus pi to plus pi, right? Let's discuss polar form. Polar form of a complex number. then you can simplify like this. C equals a square root of a squared plus b squared times a over a squared plus b squared all the square root plus I times can you tell me what did I do here? Hello? What did I do?
So multiply the top and the bottom with the
Yeah.
a squared plus b squared root.
Yeah, by taking modulus of actually this is actually a square root of a squared plus b squared is the modulus of this complex number.
Modulus of C.
That is length OP.
Yes, sir.
This length OP, right? This length OP.
Yes, sir.
Now what is this one? A over square root a squared plus b squared is what? A is this length, B is this length, A over this length, x coordinate divided by the this length, that is y revolving length of the revolving line like this, no? A over this length is cos theta, no?
Yes, sir.
Cos theta plus B over this one, B over this length, sin theta. Right? So this also you can take R cos theta plus sin theta. Right? So theta can be determined from the equations cos theta equals A over A squared plus B squared and sin theta equals B over A squared plus B squared whole thing squared, like this. You can define like this, right? So if you confine to one circle, right? If you confine to one circle, theta has single solution. Theta has single solution, right? Or one circle or one period. If you confine to one period you can take unique solution for theta. What do you mean by if you confine to one period? මොකක්ද ඒකේ තේරුම? එක period එකකට අපි සීමා වුණොත් you can have only one solution for theta. What do you mean by that? If you take cos theta equals minus half, sin theta equals root 3 by 2. What is theta?
Minus half cubots, which would be 90 plus 60.
Cos theta equals minus half. Cos theta equals minus half. Sin theta equals root 3 by 2. What is theta?
Yes, sir.
What is theta?
150 degrees.
100?
50 degrees.
120.
90 plus 16, sir.
120. Cos 120 cos 2 pi by 3 is minus half. Cos 120 root 3 by 2. Right? Is that all? You can you take theta only? Is it the only answer for theta?
No, sir.
So what are the other answers? Other solutions for theta? I am asking that if cos theta equals minus half and sin theta equals root 3 by 2. Right? If you confine to one period or one circle, means you confine to either one from 2 pi to 4 pi is a one cycle, one period. Then 4 pi to 6 pi also one period. Is it clear? 0 to 2 pi also one period. Okay. This range covers 2 pi. Each of these complete circle. One circle completes from in this range exactly. If you take unit circle, so this is the revolving line starting from x-axis. If you rotate from 0 to 2 pi, one circle completes. Right? If you again from 2 pi to 4 pi also another circle like that. Right? Or one period. First period is from 0 to 2 pi. Second period is 2 pi to 4 pi. Third period is 4 pi to 6 pi, like that. If you confine to single period, you have single solution. That single solution is, if you confine to from 0 to 2 pi, you have only one solution, theta equals 2 pi by 3. That is 120 for this one. That is what I said. Is it clear?
Sir. Yes, sir.
Like that. Single solution it has. Or you can see in different way. Different way means, now if you confine to this also a single period, so you can measure from this direction, you measure up to 5. From this side also you can measure up to minus 5, like this. Right? Angle you can measure like that. From minus pi to 5 is one period. Right? Then like this. Then 5 to 3 5 is another period, like this. In this manner also you can measure periods, like this. Okay. This also period 2 pi. This covers 2 pi, range 2 pi, right? Okay. In this manner. Right. When you take in the polar form, you can express any complex number in this form. This is very easy to do it, right? Some additional things also I mentioned, not actually additional, those are very important, right? Important things, you need those, you have to understand deeply, no? If you understand it deeply, you need that. Now, how do you define theta? Can you take for theta any solution for theta? Yes. In polar form, you can put any solution for theta. This is the polar form. But this is unique expression, right? Unique expression. Uniquely expressed like this. For example, why we call unique expression? Not in different way. For example, if you take C equals 2 times, let's say cos pi by 2 plus sin 3 pi by 2. Is this polar form of a complex number? This is not a polar form of a complex number, because here cosine, here sine, but these angles are different. Always there should be same angle here and here if it is polar form. Here should be a positive number, right? Right? Like this, not the polar form. Express followings in the polar form. Right? Example 1. C equals 1 plus I. 2. C equals 1 plus root 3I. C equals minus root 3 plus I. C equals 1. 4. C equals minus 3I. C equals minus 2. C equals plus 4I. How do you express this in polar form? These complex numbers, how do you express polar form? Right? Polar form. Let's see one by one. If you take C equals 1 plus I. So you can take what is A, what is B? A is 1, no? B also 1, no? B is coefficient of 1.
Yes, sir.
Then square root of A squared plus B squared is square root 2, no? 1 square, square root of 1 squared plus 1 squared. That is square root 2. Take square root 2 out. 1 over root 2 plus I times 1 over root 2. Then root 2 times. So 1 over root 2 is cos pi by 4 plus I sin pi by 4. Okay? Like this. Is it clear? C equals minus 1 minus root 3I. Now if you take second one, C equals 1 plus root 3I. What is square root of A squared plus B squared? 2, no?
No, sir.
Half plus root 3 by 2I. So 2 times, this half is cos pi by 3 plus I sin pi by 3. So you keep in mind always when you express in the polar form, always cosine term should be here, sine term should be here. you cannot use different angles here and here. There should be same angle here and here, right? And other thing is here, this coefficient here, this number here, R, always magnitude of a complex number or modulus of a complex number. Modulus of a complex number always non-negative. Therefore, here should be positive value. Outside the brackets, there should be positive number, right? You
Yes.
can't keep negative number. You can put negative number, but you don't consider that number as in polar form. If we have minus sign here, but that is not a polar form of that complex number. If you take it polar form should satisfy those conditions, right? Otherwise, it is not polar form, right? Right. If you take third one, C equals minus root 3 plus I. So you can take 2 out, minus root 3 by 2 plus I into half. So this equals 2 times. Now here cosine is negative, sine is positive. What is the angle? Can you tell me? Roughly you can guess, then thereafter you check. 120 or 150. That is 2 pi by 3 or pi by 6.
So it should be 90 plus 30, 120.
No. Trigonometry knowledge, you have to make your trigonometry knowledge. Cos pi by 6 plus I sin pi by 6. So this is polar form, right? This is polar form. Okay. Right. Then fourth one. Can you tell me what is polar form of fourth? This is a complex number. 4 is a complex number. What is fourth one? C equals 4. If you set in the complex number, very easily you can amplitude you can tell that. What is the amplitude? Now 4 is here, no? Number 4 is here.
Yes, sir.
What is the argument?
0. 0.
0. Yeah? Then you can write this C equals 4 times this equals 1 plus 0I, like this. So this equals 4 cos 0 plus I sin 0. So this is the polar form of Z equals 4. Okay. Right. Then fifth one, C equals minus 3I. C equals minus 3I. Where is minus 3I? In the Argand diagram. Minus 3I is here.
So on the y-axis.
3I. Right? On the y-axis. What is this angle?
170 degrees.
Yeah, 2 pi by 6. So 3 equals, always you have to take positive number out of the brackets. Take positive number out of this bracket. Then you have 0 plus minus 1i. right? So 3 into cos 3 pi by 2 plus I sin 3 pi by 2. I would like to mention one important thing in this stage, right? 3 pi by 2 is argument, arg-z. So you call this arg-z, argument, argument. We known as arg-z, arg-z equals 3 pi by 2. Not only that, you can select many arguments. There are many arguments. There are many arguments. Many arguments means now arg-z equals 2n5 plus 3 pi by 2, where n belongs to z. Right? All coterminal angles of 3 pi by 2 are arguments. Many arguments. Right? Many arguments. පැහැදිලි නෑ.
පැහැදිලි සේක පීරියඩ් එක තියෙන මේ
අපිට තියෙන many arguments. මේ 2 and 5 2 5 වල multiples you can add කර කර ඕන තරම් arguments තව ගන්න පුළුවන්. ගොඩාක් ගන්න පුළුවන්. Infinite number of arguments you have. Out of this infinite number of arguments, there is a principal argument. What is the principal argument? Principal argument. Principal argument is denoted by capital ARG. Starting from capital ARG, arg-z, that is only one, that is unique, that is actually minus pi by 2. Right? Principal argument principal argument always selects so that the principal argument is selected in the range. The principal argument is selected in the range. What is the range? Do you know that range?
Minus 5 to plus 5.
Minus 5 less than theta less than or equal 5. In this range. No equal sign here. Keep in mind. No equal sign here. Here you have equal sign also. Right? That means there is no argument called minus 5. Principal argument you have to choose in this manner. Right? Better when you express a complex number in polar form, always you can select the principal argument. That's good. But for the principal, no need to select the principal argument. For the polar form, it is not compulsory to select principal argument. Right? But it is good if you select principal argument. That is convenient for you. Principal argument. Right? Principal argument you denoted by capital ARG set like this. Right? Is it clear?
Yes, yes.
Now you select, now you take next one, 6 minus z equals minus 2. If z equals minus 2, so this equals 2 times minus 1 plus 0i. What is the argument? Can you tell me straight away? Where is minus 2 in the Argand diagram? Then you can imagine the angle at once. In terms of principal argument, tell me the angle. Minus 1 plus 0i. Minus 2 is 2 times minus 1 plus 0i. What is the corresponding angle? Where is minus 2 in the Argand diagram? Hurry up. This complex number is on the negative x-axis. Minus 2, where do you mark this complex number in the Argand diagram?
In the exactly negative, make it 2.
On the negative x-axis. Then what is the principal argument corresponding numbers on the negative x-axis? Either plus pi or minus pi.
Plus pi, sir.
Plus pi. Minus pi, you cannot take minus pi, no? In this case,
Yes,
minus pi does not include, you see? Here no minus pi in the principal range. Therefore, this equals.
So, sir, then 3, 6, that 2 pi is minus pi corresponding.
Yeah. Cos pi plus I sin pi. Okay. Cos pi plus I sin pi. Is it clear? Right. Then next one. Can you tell me? Is it z equals 4i? That you convert in the polar form.
The theta is 90 degrees.
C equals 4, 90 degree. In terms of radian, cos pi by 2 plus I sin pi by 2. Right? So this is seventh one, this one. Right? Then C equals minus 1 minus root 3i. So square root of a squared plus b squared is what? 2, no?
2, sir.
Minus half plus 3 by 2i. How do you guess this angle, do we? Very simple.
240, sir.
240, yes. 240 or 4 pi by 3, no? 2 times cos 4 pi by 3. Because if both numbers are negative, that is this complex number is in third quadrant. Yeah, you should understand that. Plus,
yes, sir.
I sin 4 pi by 3. Okay? I sin 4 pi by 3. So that is the last one. Right. Let's see the tute. 6 1. Sixth one is
So
this
for the
one. C
principal
equals minus 2,
argument,
no? C equals
yes, sir. The
minus.
principal argument is pi.
Principal argument is pi, yes. Pi plus
Okay,
pi.
sir, then.
Yeah, plus pi.
Thank you, sir.
This one. Principal argument is pi. So you can write minus 1 plus 0 I. Minus pi, cos pi equals minus 1, sin pi equals 0. Right. Now, if you look at the question number 1 in this tute, only you have to do algebraic operations for simplify and express in the form of a plus ib, right? If you express in that form, then you can say both real part and imaginary part of each of these complex numbers, right? I think first sum is you can manage. First one you can manage. If you come to second one, check whether you can manage that sum. Find algebraically the modulus and the argument of the complex number. Minus 1 plus I all into the power of cube over 1 plus I to the power of 4. Can you do that one? Second one.
Okay, sir.
So you can simplify like this. So minus 1 cube plus 3 times minus 1 squared I, 3 times minus 1 I squared plus I cube over 1 squared plus 2I plus I squared whole thing squared. Minus 1. So, you know expansion of a plus b cube, no? So you can apply like this. Plus 3I plus 3 minus I over 1 I squared. I squared is minus 1, I squared and this one get cancelled. Then 2I squared is 4I squared. So this equals 2 plus 2I by 4 minus 4. So this equals minus half I. Then what is imaginary part? If you take this is C, what is real part? Real C is minus half. What is MC? Imaginary part of C also minus half. Both imaginary part and real part are equal to minus half. Is it clear? Right? So you can take this G, complex number C, the entire complex number. Now they ask find this complex number in polar form, no? So this equals root 2 by 2 1 over root 2 minus 1 over root 2 I. 1 over root 2 times cos minus 3 pi by 4 plus I sin minus 3 pi by 4, like this. Okay. Cos minus 3 pi by 4 plus I sin minus 3 pi by 4. We give the principal argument for the argument. This angle is principal argument. Because actually if you mark this complex number in the xy plane, this point, here minus half, here also minus half, x, y, like that. What is this angle? This angle is 3 pi minus 3 pi by 4. That is the argument of, principal argument of this complex number. Minus 3 pi by 4. Is it clear?
Yes, sir.
Third one, I will leave for homework. Third one. Fourth one also for homework. So you do today itself. If theta is g equals cos theta plus I sin theta and theta is an acute angle, find the argument and the modulus of 1 plus g. Can you do fifth one? Fifth question.
Okay, sir.
Cos theta is equals cos theta plus I sin theta, and theta is an acute angle. So this is given. Then you have to express 1 plus c in polar form. 1 plus c means 1 plus cos theta plus I sin theta. One plus, this can be written as 2 cos squared theta by 2 minus 1. This can be written as 2I sin theta by 2 cos theta by 2. Okay. Then here 1 get cancelled. Then you take 2 cos theta by 2 out. If you take 2 cos theta by 2 out, here you have cos theta by 2 plus I sin theta by 2. That's all. Is this a polar form? Is this the polar form? Is this the polar form of this 1 plus g?
And also the outside there's a cos theta also with the radius.
Yeah, theta is, you have to consider theta is known value. Not only you know the range of theta also. If you take theta is known, this is positive. How do you say this positive number? 2 cos theta by 2. Is positive or negative?
Plus 0 to pi over 2.
Because this
Sine
theta is
cosine.
acute angle, then cos theta by 2 also acute angle. Therefore, this is a positive number. Outside the bracket you have positive number. Here you have cosine, here sine. Right? This is a general format of polar form. Therefore, what is argument? Then arg 1 plus g equals theta by 2. Mod 1 plus g equals 2 cos theta by 2. Okay. Arg 1 plus g equals theta by 2. Argument is theta by 2. And modulus of 1 plus g is 2 cos theta by 2. Okay. So this is the polar form of 1 plus g. Very simple. Right? Okay. Now you can do question number 6. Solve the equation x cube equals 1. Express each of the roots in polar form. Question number 6. X cube equals 1. Right? This is a cubic equation. If it is a cubic equation, there should be 3 roots. Right? If you come across this equation in any other lessons, normally you have 1 root because always you consider only real roots. But in this lesson, we consider all 3 roots. Right? You know that this equation has 1 real root. Other 2 roots are imaginary. Right? So, how do you solve this? You can factorize this x cube minus 1 cube equals 0, right? X minus 1, x squared plus x plus 1 equals 0, right? So, x equals 1. Then other one is, you can factorize x plus 1/4 whole thing squared plus 3 by 4 equals 0. Right? Then x plus 1/4 whole thing squared equals minus 3 over 4. The x plus 1/4 x plus half, no? X plus half whole thing squared. X plus half whole thing squared. X plus half, if you complete perfect square, this equals x equals 1 or x squared plus x plus 1 equals 0. So you can complete square for this one, that is x plus half squared equals 1. Then x plus half equals plus or minus square root minus 3 over square root 4. That is plus or minus square root 3 by 2 times minus 1. That is plus or minus square root 3 by 2i. Then other 2 roots are x equals minus half plus root 3i by 2 or minus half minus root 3 by 2i. Now, how do you express in polar form? There are 2 roots. 1 is equal to cos 0 plus I sin 0 minus half plus root 3i by 2 equals cos 2 pi plus I sin 2 pi by 3. Then minus half minus root 3 by 2i equals cos minus 2 pi by 3 plus I sin minus 2 pi by 3, like this. The important thing is, if these three complex numbers is on the unit circle. What is a unit circle? Unit circle is the circle with radius 1, right? Unit circle is with radius 1. In the Argand diagram, these three complex numbers always on this unit circle, each root is of modulus 1, right? Each complex number has modulus 1. And how do you find the roots? Root 1 is 1 here. Other root is symmetrically distributed like this. These are the three roots. This is minus half, minus root 3 by, plus root 3 by I. This one plus half, minus half, minus root 3 by 2 I, like that. On unit circle, you can mark these three roots like this. This 2 pi by 3, this angle minus 2 pi by 3. Okay. Is it clear?
Yes, sir.
Then question number 7, x cube equals minus 1. Express each of the roots in polar form. Right, this one. X cube equals minus 1, x cube plus 1 equals 0. Then you can factorize x plus 1, x squared minus x plus 1 equals 0. X equals minus 1 or x squared minus x plus 1 equals 0. X squared minus x plus 1/4 plus 3/4 equals 0. 1 can be separated into 1/4 plus 3/4. This is the coefficient of x is 1, it's half the coefficient of x is half, square of half is 1/4. So this part you can write x minus half whole thing square equals minus 3 by 4. X minus half equals plus or minus root 3i by 2. X equals half plus or minus I root 3 by 2. So these are the other two roots. Then minus 1 equals cos pi plus I sin pi. Then half plus I root 3 by 2 equals cos pi by 3 plus I sin pi by 3. Half minus I root 3 by 2 equals cos minus pi by 3 plus I sin minus pi by 3. Right? Very easily you can find the roots of that equation and express in polar form. Okay. Now solved in equations, if you take solved in equation, can you solve this equation? Z squared equals I. Can you solve this equation? Solve Z squared equals I. One small thing forget to do. That is equality of two complex numbers. මට මතක අමතක වුණා ඒක කරන්න. හැබැයි very simple දෙයක්. ඒක දුව දාන්න. You know that, eh? Very simple thing. How do you equate two complex numbers? If two complex numbers are equal, if real parts equal separately and imaginary parts equal separately, then two complex numbers are equal. Right? Real parts දෙකත් සමාන නම්, imaginary parts දෙකත් සමාන නම්, complex numbers are equal. Right? ඉතින් දුවයි ඕක කියන්න නැතුව නේද? ඒක දෙකම එක වගේ නේද? If both things appear to be same, it is obvious. නේද? එහෙම හිතනවා නේද? ඕක කියන දෙයක් නේද? Real parts are equal now. Real parts also equal, imaginary parts also equal, then they are equal. Then why do you emphasize that? What is the reason to emphasize that? Reason is you can do many things using that. You can solve equation of this form. මේ වගේ equation solve කරන්න පුළුවන් equality condition එක පාවිච්චි කරලා. Right? Equality condition එක. So using that equality condition, you can solve this type of equations. Right? Now you try doing how do you do this? You can assume root of this equation equals C equals A plus IB. You think one root of this equation is equal to A plus IB. Let the root C is A plus IB. That is G equals A plus IB. If this is a root, this satisfies this equation. Right? That is A plus IB whole thing squared.
So that means the AB equals 1. The AB product.
Yes. Equals I. Then this equals A squared minus B squared plus 2ABI equals I. Now equating real part and imaginary parts separately. Then A squared minus B squared equals 0. 2AB equals 1. Is it clear? A squared equals B squared. A squared equals B squared. Here AB equals half. From this AB, if AB equals half, AB is positive, product is positive. What can you say about signs of A and B?
Either both negative or both positive.
That's right, both positive or both negative, right? Both positive or both negative. Then, so you can take A equals B. A equals B, then you have A squared equals half, B squared equals half. So, are these two same equation or different equation?
Different equations.
Same equation.
Why is
Because this satisfy, both A and B satisfy this sequence, T squared equals half. That means
the
both A
independent
and B are
variable.
roots of this equation. A and B are roots of this equation. Right? A is satisfied by this equation, B also satisfied by this equation. Right? Then this equation satisfied by A, this equation also satisfied by B. Then both A and B, this equation is satisfied by A and B, therefore A and B are roots of this equation, then T equals plus or minus 1 over root 2. So you can take 1 root A, you take A equals 1 over root 2, then B equals minus 1 over root 2. A equals half, A squared equals plus or minus root 2. So you have to consider three equations. A squared equals half, B squared equals also half, then A squared equals, you just solve only, you take A squared equals half, A equals plus or minus 1 over root 2. If A equals 1 over root 2, B also 1 over root 2. If A equals minus 1 over root 2, B is equals minus 1 over root 2. Accordingly, how many roots are there? Then two roots are, what are the two roots? Roots are plus or minus 1 over root 2 plus I into 1 over root 2. Right? Always two roots available in the form of plus or minus something. Two roots can be expressed always in the form of plus or minus something, like this. Always when you solve any equation of this type, you have plus or minus roots. Can you say one root is negative, other root is positive? In that manner? You can't say like that. But it is in plus or minus form. Right? If it is real equation, for example, suppose if you have, let's say, x squared equals plus 4. This has two roots, x equals plus or minus 2. One root is positive, other root is negative. Right? Here also you have two roots in plus or minus form. But here also now you solve c squared equals I. Right? So you have two roots plus or minus form. That does not mean one root is positive, other root is negative. Because, right? Whether root is positive, whether roots are negative, that is applicable only real numbers, no? If it is complex number, you cannot apply that that nature, no? That nature is not valid for real numbers, complex numbers. Only positive or negative story of positive or negative you can consider only for real numbers, right? Then how do you solve this equation?
So assume again x equal give the x root to be x plus
This equation,
a plus I b x root is a
if you take +1, you know how to solve +1. Let now z squared equals -5 minus 12i, right? Let z equals a plus ib. Then a plus ib squared equals -5 minus 12i. A squared minus b squared plus 2abi equals -5 minus 12i. Then a squared minus b squared equals -5. 2ab equals -12. So you can equate real parts and imaginary parts separately, right? Then here ab equals -6. AB product is negative, then what can you say? If A is positive, B is negative. If A is negative, B is positive, right? So A and B get different signs, right? A and B. So you have to conclude that is very important. A and B have different signs because this is negative. If one is positive, other one is negative, right? So then a squared minus 6 over a squared equals -5. Then a to the 4 minus 36 equals -5a squared. A to the 4 plus 5a squared minus 36 equals 0. So a squared minus 9, a squared plus 4 equals 0. One important thing, a and b are real numbers. Then this part cannot be 0. This is not equal to 0. A squared cannot be -4. Why? What is the reason? Why a squared cannot be -4? Tell me, what is the reason?
Because they are real numbers.
Yeah, a and b are real numbers. Always at the beginning of this lesson I told you, when you express a complex number in the form of a plus ib, both a and b are real. Imaginary part also real, real part also real, right? So then a squared equals 9. A equals plus or minus 3, right? Then what is b? When a equals 3, b equals -2. When a equals -3, b equals +2. Then what are the two roots? One root is c equals 3 minus 2y, other roots c equals minus 3 plus 2y. Are these two roots expressible in the form of plus or minus? Plus or minus 4? Is it expressible in the form of plus or minus 4?
Can, sir.
Can or cannot?
Can, sir.
Can, yes. Then both roots can be expressed as plus or minus 3 minus 2y. So you can put inside this bracket any of the roots. So you get the both roots from this expression. Is it clear? Right. Okay. That means 3 minus 2y whole thing squared, if you take this one, squared equals minus 5 minus 12y. If you take minus 3 plus 2y squared, that is also equal to minus 5 minus 12i. Is it clear? Both roots satisfy this equation. Is it clear? Right. If you come to next one, second one, right? If you come to second one, right? Two c into 1 minus 2i plus 2 minus 8i equals 8. When you solve this equation, there are two steps, right? This includes two steps, right? So step one is complete a square. Complete a perfect square. In left hand side. Second step, to find square root of right hand sides. When you solve this equation, you have two steps. First step is complete perfect square in left hand side. Second step, to find the square root of right hand side. Then you might say you have not done finding square root of a complex number. Would you say like that? Would you say you didn't do finding square root of a complex number? Here what did you do? This is actually finding a square. This sum you can say in different way. Find the square root of minus 5 minus 12i. For the square root of this complex number has two values. It is same as solved in this equation. Right? Parallel doing.
Oh, sir. Parallel, sir.
Right? May way solve this equation. One, first you have to do the complete and perfect square. Second part is to find the square root of right hand side. let's see how you can do. C squared. So you take, what is half the coefficient of C here? 1 minus 2y. Same way, when you complete perfect square, 1 minus 2y plus add 1 minus 2y whole thing squared and subtract 1 minus 2y whole thing squared plus 2 minus 8i equals 0, like this. Okay. Half the coefficient of C is 1 minus 2y here. So its square you add and subtract, or add to both sides, both same. For this part you can write C minus 1 minus 2y whole thing squared. Then other part you simplify, right? Take into right hand side 1 minus 4i plus 4i squared minus 2 plus 8i, right? Then this equals 1 minus 4i minus 4 minus 2 plus 8i. Here minus 6 minus 6 plus 1 minus 5 plus plus 4i. Okay, minus 8i. Sorry, here minus 8i. Some small correction, right? Here minus 16i, so that you can have some simple values. 2 minus 16i. Then here 2 minus 16i. Then minus 2 plus 16i. Minus 2 plus 16i plus 16i. Then this equals minus 5 plus 12i. Minus 5 plus 12i. Right? So here I make some small change in this sum. Here 16i, right? Minus 16i. 2 minus 16i. Okay. Now you can get. Now first part is over. Complete in perfect squares. Okay now. This side equals minus 5. Then you have to find the square root of this one. How do you find the square root of this one? You just take a plus ib whole thing squared equals minus 5 plus 12i. Okay. Then is step 2. Step 2. A squared minus b squared plus 2abi equals minus 5 plus 12i. Then a squared minus b squared equals minus 5. 2ab equals 12. AB equals 6. Right? Now both a and b are positive. Now you can solve a squared minus, for b you can substitute 36 over a squared minus 5. Right? So you have a to the 4 plus 5a squared minus 36 equals 0. So you can factorize this. A squared minus 9, a squared minus 4 equals 0. Here plus 5, here plus 9, minus 4 equals 0. Like that. Now this not equal 0. Therefore a squared equals 4, a equals plus or minus 2. Right? Then what are the b values? A equals 2, b equals 3. A equals minus 2, b equals minus 3. Because similar signs, both a and b get similar signs. Then what are the roots? So c equals plus or minus, right? That means square root of minus 5 plus 12i equals plus or minus 2 plus 3i. 2 plus 3i. Right? Now, next part is very easy. Right? Next part is very easy. Now you just take this like this. Then c minus 1 plus 2i, 1 minus 2i, sorry. 1 minus 2i, 14 squared equals minus 5 plus 12i. When you take square root, 1 minus 2i equals plus or minus 2 plus 3i. So you can find two roots taking z equals 1 plus 1 minus 2i plus or minus 2 plus 3i. Then if you consider plus sign, c equals 3 plus I. If you consider minus sign, c equals minus 1 minus pi I. So these are the two roots of this equation. Okay? So you just take 2009 A level or 2010 A level question. I can't remember exactly. In 1 year you have this type of problem you have to solve. You can manage that sum. Okay.